So this is our brand new next generation laser for our device, which is all set and ready to ship for our clinical trial. A lot of work has gone into this. A lot of the last webinar, we talked about some of the validation and verification work that's required to do of it to effectively establish and be able to share with ethics committees and various other regulators that what we say it does, it actually does. That work was done by a top-notch company in Canada, and we're very, very pleased with that validation, the results and the end unit, and we've made a number of enhancements to it. That's the hand piece on the side. That fiber you can see on the right is literally the fiber the laser passes through, and this makes it an easier hand grip for the operator to use. Carmen, you've played with this a little bit. Do you want to make any comments on the new version?
Yeah, this is a very elegant device. It's nimble. It's very reliable. We've confirmed, the company has confirmed that the energy is reliable. It's consistent. It's got all kinds of built-in safety measures, and so we can adjust the wavelength that we use is 860 nanometers, and so at that wavelength, that's an optimal wavelength for treating tissue. It penetrates 2.5 centimeters or so, and my American friends reminded me yesterday that's an inch, and so it penetrates an inch into tissue. And there is, if you look at any cavity in the body, we can either target a tumor from the surface or from some lumen, like a colon lining or urethra and a prostate or a rectum. So this gives us lots of access to tumors, and without the invasive component that every other technology needs to get there. And so that's another. So this machine is super well crafted. The simplicity of that handle, if you've ever been in a clinic, to be able to hold a unit like a pen over a tumor is both relaxing and comfortable for the treater, and it gives it lots of flexibility as to where you can aim it on a patient. And we actually have a kind of a little tripod fancy stand that holds that up. But the long and the short of it is this is a very comfortable device for a treater. And when we make these kind of things, you need utility and consistency, and this we're very excited about this. So that's another Sona development. We haven't talked about it very much because it's really the nuts and bolts of it, but at the end of the day, this is an improvement. And that wavelength is, if any of you have looked into laser technology, you'll see this is the optimal wavelength to treat these things, to use for this purpose.
And that's why we needed a custom made laser. This was not an off-the-shelf possibility, but if you want to get that depth of penetration, this is what was necessary. And so very pleased with what we have. And as I say, as Carmen says, it then allows us to go into any number of different types of tumors in different locations. Of course, starting with melanoma in this first early feasibility study with humans. But from there, we already have plans to move on to others. I'm going to just pause here because there are a number of questions. I want to try and address some of them. Carmen, do you believe possible outcome with BioVax's research could lead to a personalized cancer vaccine of sorts in time?
So great question. With or without BioVax's, the technology that we have can lead to a personalized vaccine. Right. So the important thing is, again, when we're generating these neoantigens, when we're dismantling a cancer cell and showing all the protein to the immune system, we are essentially personalizing the vaccine. I'm going to show you some data in a few weeks to prove that concept in the animal experiments we're doing now, the preclinical models. What we hope is that the DPX will increase the incidence of that experience. So it can, if we can optimize that even 10% further, that makes us even better. But we have, again, I'll show you the data, but the answer is with or without the DPX, we will in the not too distant future be talking about personalized clearance. Curing cancer is essentially, with an immune therapy, is a form of vaccination.
That's it. And of course, this is our, we refer to this as our laser, but the reality is this is a near infrared light that we're using, uses laser technology, but it's not the same as the type of laser you'd have in a surgery doing cutting. Pointing this, the skin does not cut. This is just done with near infrared light in order to pass that gentle, non-thermal energy through tissue that then hits the gold nanorods that have been injected in the tumor. They start to vibrate and cause heat, heating the tumor from the inside out again.
And that's an important point. I'm just going to jump in. That this makes it speaks to the safety of this and the wide the wide applicability of it, because at 850, 860 nanometers, you're getting to the top point before you have to start worrying about superficial tissue damage. All of the lasers in the ORs that we use to cut and ablate tissue are literally cutting and ablating. But it is in the laser spectrum, so that's why it's loosely spoken to. But it's the near infrared light end of it.
Great point. Thanks for that point raised.